This is chapter 11, exercise set D, problem 2. So we have fathers have an average height of 68 inches and an SD of 2.7, and sons have an average height of 69 with an SD of 2.7 as well, and the correlation is 0.5. Now, specifically part B was asked. It says, if a father is 72 inches tall, predict his son's height. For these, we're going to use what's called the regression method. It's kind of unfortunate. This one doesn't actually have like a nice formula. It's kind of hard to truly tell you the steps. Is more of it's just steps. You have to kind of work through it quite a few times until you remember how to do it. So the first step is we want to find Z for the fathers. Okay, so we'll say something like, if the father equals 72, then his Z value, well, remember Z equals X minus the average over the standard deviation. So for him, his height is 72. We'll minus the father's height. Make sure you do the father's because we're talking about a father right now, of 68, over a standard deviation of 2.7. Which gives me 1.48. Now remember, what does a Z value tell you? Z value always tells you how many standard deviations you are above the average. So this tells us that this father is 1.48 standard deviations above the father average. Now, it'd be easy to say, well, if the father is 1.48 standard deviations above, then the son should probably also be 1.48 standard deviations above. But that would be based on the SD line, and we figured out that doesn't give us good predictions. What gives us better predictions is our regression line. And to change the regression line, you have to multiply this Z value by R. So now we need to find R times Z. So this was kind of like our first step. That was our first step. This will be our second step. So in our case, R is 0.5 times that Z value of 1.48, which gives me 7.4. Wait, that is 0.5. Sorry, I typed that in incorrectly. 0.74. So now our next step, so the first step is find the Z value for the father. Next step, times it by R. Final step, or well, not final step, next step, find the Z value for the sons. Okay, which is what we just found right here. So this means the son should be 0.74 SDs above the son average. Now, you could come up with a formula here, but I just like to use logic. So he should be 0.74 SDs above the average. So it should be like 0.74 times the standard deviation plus the average for this son. So this will be 0.74 times the standard deviation for the sons, which is 2.7. Plus the average, make sure you do the average of the sons, which is 69. So this gives me 70.998. So we would predict that a son that comes from a father of 72 inches will probably have a height of about 70.99 inches.